Okay, this is number 1 of page number 8 in your lectures. Uh, this time, we're gonna deal with the dependent sources. Dependent sources. So dependent sources, as we have discussed already, they depend on value of current or voltage somewhere in the circuit. And for this example, the value of this is dependent on the value of IA. It is actually 5 times IA. So if we got the value of IA, then we can now get the value of this current source, which is 5 times IA. So this is still part of KCL and KVL. So the question here is, the unknown is VO, and we are asked to get the value of VO. The VO is the voltage across the 20 ohm resistor. So let us start. So KCL and KVL, we don't have any choice. We determine the nodes and the loops. So where are the nodes? This one and this one. But they're just the same if we perform KCL because they connect the same branches. So let us call this node 1. And then we determine also the polarities. Now IA is towards this direction. Therefore, the polarity of this is plus and minus. Now the polarity of the 20 ohm resistor is already given. And here, since the direction of the current is going up, so we assume that the voltage, because this is a current source, it is supposed to deliver power. So this should be positive and this should be negative. And this one is also the same as VO. This is also VO. The voltage across 5 times IA is also VO since they are in parallel. Okay, so the current flowing through this branch is 5 times IA. And the current flowing in the middle branch is IA. It's actually going IO, and it's going down. Okay, let's start. Since we don't have any choice, let's start with KCL and then KVL, okay? So KCL first. So KCL at node 1. So entering and leaving currents equate to 0. So we have negative IA, negative since current is going towards the node, plus IO, and then 5IA is going towards the node, that's why it's negative, so 5 times IA equals 0. Or simply, this is negative 6IA, combine 5A and IA, plus IO equals 0. So this is our equation number 1 since we didn't get anything from that. We need another equation of IA and IO so we can solve for their values. Now, we can perform KVL here, here, or the outer loop. But since our unknowns here, our variables are IA and IO, we can perform our loop 1 here, KVL here. Why? Because IA is here and then IO is also here. So they will be part of our next equation. So KVL at loop 1. So let's start with 500. So negative 500. Why negative? Because it enters the negative terminal. And then the voltage here is plus 5 times IA. Then the voltage here is VO, or VO is actually 20 times IO. So plus 20 times IO equals 0. Or simply, this is in the form of this A, IA, and then IO, and then constant. So this is 5 IA plus 20 IO equals, transpose 500 to the negative, to the positive, to the right side, equals positive 500. So this is now equation 2. Since we have two equations and two unknowns, we can now get the values of IA and IO using equation on your calculator. So mode, let's go to equation, then two unknowns because we have only two unknowns. Okay, so the coefficient IA1 is negative 6. Then B1 is 1. And then C1 is 0. And that is for this equation. Now let's go to the next equation. This one. So 5. And then 20. And then 500. So the answer is, sorry, kamali. Start A1, 6, negative 6, and then 1, and then 5. No, this should be 0. And then A1 is 5. Then 20. Then C is 500. So our IA is 4. And our IO is 24. This is 4 and this is 24 amperes. Okay, so can we get now the VO? Yes. VO is, as we have said a while back, the voltage across 20, so 20 times IO. 20 times IO. Therefore, this is 20 times, what is IO again? 24. So our VO now equals 20 times 24. Times 24. 20 times 24, 480. That's how you do it.